Let's begin our new topic of vectors, chapter 20 of the textbook. First, we have to ask, well, what is a vector if we're going to study them? So you can imagine a vector is similar to a line. It has magnitude or length, but it also has direction, indicated by an arrow, from where the vector starts to its finish point. It's basically the most direct way of getting from one point to another point. Some examples of vectors be velocity, as that has speed and direction. Example, wind velocity is 20 kilometers per hour east, or displacement, which is distance and direction. For instance, Leeds from York is 25 miles, that's the length you're traveling, and the direction is west. So vectors can be drawn as straight lines from one point to another. They can also be denoted or written as what we call column vectors, where A1 in our column vector, or the first component, is the change in the horizontal direction, and A2, or your second component, is the change in the vertical direction. I'm going to draw in 2 points. Point A is 1, 2, and point B, that's going to be the point 5, 5. Imagine you wanted to get from point A to point B in the shortest length of time. Obviously, that would be using a straight path, and you could put the arrow in saying you're starting at A and then ending up at B. We could write this vector or this path here as a column vector. I'm going to call this vector AB, and that little hat on top denotes it's a vector. Then you ask yourself, how far horizontally do I have to move from A to get to B? So what is the change in x coordinates? If you're moving right, this change will be positive. If you move left, the change will be negative. We're moving right, and to get from x equals 1 to x equals 5, we are simply moving 4 units across. The second component of this column vector is the change vertically. So how do I get from y equals 2 to y equals 5? If I go upwards like I do in this situation, this component will also be positive. If you are moving downwards though, this component would be negative. And I know to get from y equals 2 to y equals 5, I would have to go up 3 units. So that is my A2. So there are a few different types of vectors. We're going to look at position vectors today. A position vector is a vector that begins at the origin, 0, 0, and it goes to a coordinate point such as A, which could be A1, A2. This vector is sometimes denoted either by OA with a hat on top or a little a and again with a hat on top. To get from 0 to A1 in the x direction, well, you'll just have to move A1 units across. To get from 0 to A2 in the y direction, well, you're just going to have to move A2 units up or down from the origin. Note, when we add and subtract vectors, we add and subtract their components. When we multiply vectors by a scalar or just a number, we multiply both the first component of our column vector and the second component of the column vector by this number to get our new vector. As you can see in this graph, we have the vector OA, sometimes denoted as little a. That vector is 1, 2. Because it's a position vector, we start at the origin. We're going to move 1 place right and then 2 places up in the vertical direction. So I'm going to actually end up at the point 1, 2. Similar to the vector O capital B or little b with a hat, if that is equal to 3, 1, I'm going to start at the origin, move 3 units horizontally, again in the positive x direction, and 1 unit vertically. So I'm going to again end up at the point 3, 1. When we add vectors A and B, notice I'm just going to add them component-wise. So my first component in vector A was just 1. My first component in vector B for the x direction was 3. So I just do 1 plus 3, and that will give me 4. I do the same with the second components. 2 plus 1 is 3, and this will give me the new vector 4, 3. To draw this vector, A plus B, remember it's just 4, 3, so we start at the origin, we go 4 units across in the positive x direction and 3 units up. So the vector AB will end up at the point 4, 3. Lastly, when we multiply a vector by a scalar, we just multiply that scalar inside the vector components. So if I have 2 times b, or 2 times vector 3, 1, I'll do 2 times 3 is 6, and then 2 times 1 is 2, and that will give me our new vector. If I draw that in, again, I start from 0, 0, and I move 6 units right and 2 units up, and the vector 2b will give me to the point 6, 2. So take your time to go through and try these examples. Firstly, I want you to sketch the vector OA, or denoted as little a, equals 1, 5 on a Cartesian plane, indicating its direction. Always remember to put your arrow in 1 unit across, 5 units up, and my vector will end up at the point, or finishing at the point 1, 5. And always label your vector, and if you can, the ending point. Part 2, write the vector little b, okay, which goes from the origin to the point B, 3 minus 2, in column form, and sketch this on the same Cartesian plane, indicating its direction. So again, to write it as a column vector, first component, think about the change in the x direction. To get from x equals 0 to x equals 3, I'm just going to move 3 places to the right. So my first component in my column vector will be 3. But for the y component, moving from 0 to minus 2, I'm going down 2 units here. So my second component will be negative 2. We're just going to compute a plus b and a minus b. But if you want to try and compute b plus a and b minus a, see what happens. Maybe this will be the same as the first, and maybe, especially for question 4, a minus b might not be the same as b minus a. So a plus b, let's write out our vectors in column form, add the component wise, and that will give you a new vector. 1 plus 3 is 4, and then 5 minus 2, well, that is just 3. So this one, start with a, 1, 5, and we're going to subtract 3 minus 2. Again, just go component-wise, 1 minus 3 and 5 minus 2. Well, that will be minus 2 on the top, and then 5 plus 2, or 7 on the bottom. Now we're going to have a look at what happens and what's the relationship diagrammatically. A plus B, let's draw that. So we start at the origin and we go 4 units to the right, 3 units up. And again, this vector will end up at the coordinate point 4, 3. But what is the relationship of A plus B to the vectors A and to the vector B? Well, really what this means is you take vector A and you're just going to add vector B, move it up to the point where A ends, and you just add it on. Let's look at the vector A minus B. So we put that in, that is minus 2, 7. So 2 units to the left and 7 units up. Again, it will end up the point minus 2, 7. What is the relationship between A minus B, your vector A, and your vector B? Well, A minus B could really be written as minus B plus A. If we times our vector B by a minus sign, instead of having the column vector 3 minus 2, I would actually have minus 3, 2. Then we would add on vector A to this, which is 1, 5. I just ran out of room to make these column vectors, but you can imagine that they are column vectors. So if I take the vector minus 3, 2, I would actually be somewhere over here. Then if I add the vector going to the right 1 and up 5 units, I end up the exact same point, minus 2. So that is a way you can visualize the adding and subtracting on vectors. And it is a little confusing to start with, but the more you do it and the more practice you get, the more you'll understand it.